So an equation is said to be separable if and only if it can be written in the form y prime equals, and then we've got a function of x only, so no y's, times a function of y only, so no x's allowed. Okay, and the reason why separable equations are useful is because in such a situation we can divide the g over to the other side. So let me write 1 over g as p, so then we've got p of x dy dx equals p of y dy dx equals f of x. So here I'm doing that one. So then let's see. Then I could go ahead and just integrate both sides of this equation, and with respect to x, like so. And then the left side by change of variables would be p of y dy, and the right side would be f of x dx. And then I could go on and solve from here. And so this is the way that I solved a differential equation with the very first example I ever gave you of how to solve a differential equation. It was a separable equation. So let's look at a particular example. Suppose I have dy dx equals x squared over y. So this is of the form function of x alone times a function of y alone. So there's my f and g. And so let's see, I can multiply the y across and we get y dy equals, and I can multiply the dx across and get x squared dx. And then I can integrate the left side with respect to y and the right side with respect to x. And if that looks fishy to you because I've multiplied across by dx and multiplying by half a symbol is not really technically a thing that makes sense, realize that I just kind of skipped to this second line right here. So it's a handy mnemonic device and a time saver to do that. So let's see. And then on the left I get y squared over 2, and on the right I get x cubed over 3 plus some constant. And to be fair, this really should have been plus some arbitrary constant c1 on the left and some arbitrary constant c2 on the right. But if I took that c1 and subtracted it over to the other side and then called the resulting thing c, I would be back at this place right here. So I will just save time and consolidate all the arbitrary constants as c. Okay, so then for this one, I cannot actually solve explicitly for y, but implicitly, this equation defines a solution to my differential equation, so I will just stay there with that one as my answer.